Hello, dear students. Today, Proposition 3 of Book 3. Proposition 3 of Book 3. If a straight line passes through the center of a circle and cuts another straight line not passing through the center of the circle in half, it bisects it, then that straight line will also be dropping on that other straight line perpendicularly. And in another case, if you have a circle and a straight line passing through the center again, cuts a straight line not passing through the center again, and now what we know is that it cuts it at right angles. In cutting that line, it will have also bisected that line, okay? So in one case, it cuts it in half. You show that it also falls on it perpendicularly. In the other case, it falls on it perpendicularly. Then you show that it also cuts it in half. So let's do it. Two props in one. Here's our circle. Here's our center. Here's our straight line passing through the center. Here is another line not passing through the center, being cut by that straight line, and it's given that it cuts it in half. Thus, it is required to show that it also cuts it at right angles, that this angle here and this angle here are both right angles, okay? So let's connect the points with the center. Okay? Now we have two triangles, and we know that this is equal to this because it's given, that bisects it, and this is equal to this because they share the same line in common, and this is equal to this because they are radii of the same circle. So we have side, side, side equal to side, side, side. And we know from our bag of knowledge, when you have side, 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 those two triangles are equal and the angles are equal. And later, by the way, we're going to use these other props. I'll show you later. Okay? So all these are equal and the remaining angles are equal, namely those which are subtended by the equal side. So this would be equal to this would be equal to this, and what we're trying to set up from the beginning is that this is equal to this. But we know when you have a straight line falling upon a straight line, making angles equal to each other, those two angles will each be a right angle. Adjacent angles equal to each other will be equal to a right angle, each of them. Straight line falling upon a straight line, creating adjacent angles equals, both of those are equal to a right angle. Quod erat demonstrandum for this part. Straight line passing the center, cutting another straight line not passing through the center in a bisecting manner, bisects it, then it will also cut it at right angles. We just showed that. Now here you have another case, a circle, a straight line passing through the center, cutting another straight line not passing through the center, and we know that it cuts it at right angles. That's given now. Thus it is required to prove that it also bisects it, that this will be equal to this, okay? Let's set about proving it. Connect the center with those 2 points. Okay, we know that those two guys are equal. That's less important right now. Let's not worry about that. Okay, so here you have two triangles again. One triangle, two triangles. And because this is equal to this big old triangle is an isosceles triangle. Therefore, the angles at the base are equal. Okay? So, let's look at these little triangles again. Here you have a triangle and a triangle with two angles equal to two angles respectively, and another side equal to another side because they have this side in common. We know then we have angle, angle, side. Two triangles with two angles equal to two angles and a side equal to the side. The triangles will be equal and the remaining sides will be equal and all that stuff. So we have two triangles, angle, angle, side equal to angle, angle, side. Therefore, the remaining sides will be equal in this, and they'll be equal triangles. So this will be equal to this. And if they're equal, this is bisecting. This and this this big line is bisected. It cuts these two in half. And it was done by this line passing through the center, cutting it at right angles. Therefore, we know if a straight line passes through the center, cutting another straight line not through the center, and it cuts it at right angles, it will also bisect that very same straight line, okay? Therefore, we have seen that if in a circle a straight line passes through the center and cuts another straight line not passing through the center, and it cuts it at right angles, in this second case, it will also bisect it. And if it bisects it, it will also cut it at right angles. Quod erat demonstrandum. Thank you. Bye-bye.